Hi, hello everyone. I'm Zachary Balaga.
I'm Alex Allen.
I'm Ed Harbison.
I'm Laura Mateo.
I'm Manasa Edwards.
Timothy Murphy.
John Spark.
I'm Daniel Stocker, and this is our project Mirrulations. So, Mirrulations is a system used to download rules from the website regulations.gov. Regulations.gov is a website where users can go and participate in the rulemaking process of various federal agencies. So they can look up rules and then they can make comments on those rules, saying their support or whether they disapprove of it, what they think of it, and then those federal agencies can look through those comments and get the general opinion and decide what to do with that rule, whether they want to go forward with it or take it back. Here is an example of what the regulations.gov homepage looks like. So if you're looking for some trending documents, over here you can see a list of them. For example, there is a document over here for the Fish and Wildlife Services about removing the protection status from the gray wolves. Basically, they want to stop their protection so that way they are no longer prevented from being killed and hunted. And if you look there, you can see there are about 46,000 comments from users. Many of them are opposed to this. They're saying they don't want that status taken away from the wolves. They think they should continue to be protected under this document. So the question we have though is, with all this information, what would someone want to do?
There is a lot of data on the regulations.gov site right now. If you are someone who wants to check in on an EPA regulation, see how many comments it has, what phase it's in, that's something you can do. If you want to see how often a company like Merck comments on a regulation proposed by the FDA, you can do that as well. If you're a data journalist and you want to see how the public response is to an FAA regulation related to drone flying, you can check a sentiment analysis on the comments, the user comments for those, and see what's going on, how the public feels about it. Public response can be a very telling metric for how a regulation is being received, especially during high-profile cases, such as the one during the Battle of Net Neutrality. There was a controversy over the authenticity of some of the user comments during the FCC's regulation proposal to repeal net neutrality. And there was a very large public response. People were very passionate about it. And as a result of this, many people flooded to many federal websites, and the amount of traffic they caused crashed some of the sites. So in the wake of this, regulations.gov through data.gov received an API to help limit some of the immediate availability of federal data so that they wouldn't experience another flood and crash on federal sites as they did before. While developing the API, they decided that they would limit access per organization to having only one key. On top of that, each key only gets 1,000 API calls per hour. So the data would be available, but in a much more limited sense. So with so much data that there is on the site, we knew that one key wasn't going to cut it for us, and we wanted to see what we could do with more keys.
So we calculated that if you wanted to try and download all of the data with only one API key, it would probably take you approximately 6 years, which is a pretty ridiculous amount of time. So the obvious solution to speeding that up is to get more API keys. We were actually able to obtain 8 API keys. The way you get those is you have to apply through regulations.gov, and they have to approve you of getting one. Not just anyone can get one. They also typically only give them out to like organizations. So once we had 8 keys, we calculated that the time would go down to about 9 months, which still seems like a long time, but it's a drastic improvement from 6 years. Currently on the site total, there are over 11 million documents on regulations.gov. And when I say the word document, that kind of encompasses the rule itself, what's proposed, all the comments that people are making on the rule, and also all the attachments that are associated with that rule. So with over 11 million documents, just to put that into perspective, it's about 4 terabytes of storage that it takes up. So that also is constantly growing every day, and there's about 50 regulate new documents that are added to the site every hour. So we wanted to make sure that if the site is always getting new documents, that we would be able to keep up. And since we have 8 API keys, that's really not much of a challenge, since there's only 50 and we have 8,000 calls that we can do every hour. So now we're going to transition into what the actual structure of Mirrulations looks like.
So last summer, a team of students built the first version of Mirrulations using volunteer computing. As Zach said, we have 8 API keys, but 8 API keys does not always mean faster. To get all of these API keys to work to their full potential, we need a server that would coordinate all the API keys. So, as seen in this diagram, the use of multiple API keys is used by having multiple clients using a single server, which then regulates the bulk of the downloading of regulations.gov. So when a client is given a set of jobs, it is from the server, it then acts with the regulations.gov API. And the server then stores all these results into the database. This next slide shows how we planned to expand the system this semester. So this was our goal design for Mirrulations. Since there wasn't enough data that we felt like it was something that we couldn't do ourselves, we decided that we were going to set a mini system to have in place to download all the data on our own. So as Zach explained, we have several API keys to help us download the data faster. So all these keys run on separate Raspberry Pis, which are then continuously download data from regulations.gov to have this all download continuously and in a small space. This data would then download to cloud storage and be accessed through a website. Our big goals for this semester were to crush a logging bug that we already knew about, get our data to download to cloud storage, and then to spend the bulk of our time on the website portion of Mirrulations.
So, one of our successes where we developed the Mirrulations.com website. Someone want to help me with that one? So,
Can I ask you just a quick question? Is that it?
The Pi cluster?
Yeah.
Yes.
Alright, so one of our plans were to create the Mirrulations.com website. As you can see, it is a bare bones website, but by entering a directory ID, which can be found within every document, document always has a direct ID. By entering the direct ID and submitting, you will download a zip file. Can we move back to the presentation?
Yeah.
And within every zip file, you would find a README and the inclusions of the attachments within each directory. So this would be the file format of our zip. So Mirrulations and Mirrulations.web uses a mirror of a document of a database that is local. So because it is local within our system, we do not need, it is decoupled, therefore we can do our separate work and we don't really clash with each other, and the website can work on our side, Mirrulations can work on their side, and we don't have that clash back. And another success that we had was the logging bug, and we can talk more about that.
So as Lauren stated before, we primarily wanted to have a certain subsection of Mirrulations be worked on this semester. So like she stated, there were some issues that were in Mirrulations, including a logging bug. We wanted to also develop the website for Mirrulations and some other options as well. We thought that multiple parts of our issues that were parts of Mirrulations would be able to be moved past fairly quickly and be able to go into new stage development for Mirrulations, such as moving into cloud storage, and a much more robust website. So, one of the strong successes of Mirrulations that we had was fixing a logging bug that cropped up in the original form of Mirrulations last summer. Basically what happens is that the client has to communicate back to the server with any information it downloads from regulations.gov. The server sends information to the client on what data should be downloaded, so multiple clients can download that information simultaneously without confusing any data between each of them. With that information that's sent back, they also send back a logging file that contains everything that the client has done with those 1,000 API calls within each hour. At each hour, it sends back this data back to the server, which is then able to record it. So if we go back in time, we can see what data the client has sent, what it's received, what it's been doing, and if there's been any issues. So if we can see that there's been an issue in the current form of Mirrulations, we can go back, figure out where it came from, track it down. However, the log file in the client side would append information to the same file and send the same file back to the server each time that it needed to post data that had gotten from regulations.gov. This was definitely an issue because, as you would realize now, as we did earlier this semester, the compounding amount of information that you'd send back would slow down drastically the time it would take for the client to send information back to the server. For instance, this quite quickly came to the case that it would actually take longer for the client to send the logs back to the server than it actually took for the client to run 1,000 API calls against against regulations.gov and send that data back to the server. This simple-ish issue that we were able to fix, however, cropped up and let us see multiple other issues that we were having within Mirrulations. The logging system was both within the client side and the server side of the Mirrulations application. It worked on the same principles and worked in a very, very similar way. However, they didn't need to work from the same data and from the same actual methods that were so tightly coupled together that basically client and server logs were one. If you tried to run the client and server on one actual piece of hardware, like a computer, they would try and write stuff to the same file. They'd also try and use the same resources in other capacities. And this tight coupling of the client and server that we first overwhelmingly saw in the logging was what presented so many large problems within the Mirrulations application.
So the logging bug and the website were successes, but they were still pretty small successes. The website was successful because it was loosely coupled, so that means that we could work on the website without having to really worry about what was happening with Mirrulations. But this is an ideal sign of design and software development because you can work on it independently, so you don't have to worry about what's happening with the other parts of the project, and also you can deploy it independently. So on the other hand though, with the logging bug as opposed to the website, it was very tightly coupled, as Timothy was saying. So that's what really caused us a huge problem. The client and server would share entities such as the logging and the config. So as Timothy was describing, when we tried to change how the logging was sent between the client and the server, it would affect both of them. So if we wanted to clear the client log each time, it would also clear the server log each time. So we had to find a way to deal with that. So also with the config, if we wanted to run the client and the server, they share the same config file. So if you wanted to just run a test on your own machine, you couldn't do that. So you had to have two different machines running. So that was another issue that we really needed to figure out how to deal with.
Now, with the issues that we were figuring out now, we realized that the project structure wasn't going to work out. All of our files were, as you can see on the left, just kind of mushed into our SRC folder. This was making everything completely impossible to run together. So with all this tight coupling, we managed to separate a lot of this stuff into its own different package for client, server, web, and then any core files that were needed to be shared. This made it possible for us to run Mirrulations, both a client and a server, on the same system, as well as test everything. And while doing this, we improved our documentation and our testing suite in order to make sure everything worked.
So along with these improvements to Mirrulations that allowed us to decouple our program and be able to work on stuff independently, we also had some other tools that we added to Mirrulations that, while not directly benefited and fixed issues within Mirrulations, allowed us to work more easily with the project structure itself. So as you all know, we are working on an open source project. It's hosted on GitHub. Each of us had forks off of this main repo, and we would each submit our code for reviews and then put it into the upstream master branch. This could be a very laborious process if you needed to make sure that all the tests ran, and like you said before, trying to run the client and server with that live code would mean an individual for the like a code review would have to get that code from someone else's branch, get the code from the master branch, combine them locally, then run it, and then assert that it works through all of our PyTests, along with other tests that we had that were manual. This helped us, in part, streamline that system. So there's a piece of software called CSCI, which is for continuous integration, that ties directly into GitHub. That allowed us to use our already in place tests for Mirrulations to automatically run against the pull requested set of code that's combined automatically with the upstream master code that's already in Mirrulations repo. This took out one large chunk of time that it would take for different developers to collaborate together in order to get a pull request through. Along with that, it also was able to check our PEP 8 writing standards for Python, which allowed us to double check that our coding style was the same throughout all of our processes. As you might know, if you have a lot of people on the team, they might try and fight over what is the right way to write something. This was a simple way of saying, that doesn't really matter. Writing something different ways just needs to be legible, easily readable, and everyone just needs to use one standard. With that, this is expandable since for PyTest we wanted to increase our testing coverage as well. Now, it doesn't fix any one problem with Mirrulations. It just helps us as a tool. Like I said before, to actually assert that it worked, we still wanted to pull that data down and run it using the actual client-server system and assert that that was working. And that took a lot of time as well. So that was another slowdown within Mirrulations that prevented quick and easy development on the project.
So setting up the system on the Pies proved to be quite difficult, and in the end we were unsuccessful with it. Overall, the problems we ran into in this area were really with inexperience with system administration. So originally over the summer, the development environment and the production environment were on Mac OS X, and then when we tried to move it over to the Raspberry Pis, the first thing we ran into was that Python 3.7 was on Raspbian, or Python 3.5 was on Raspbian, sorry, we were using Python 3.7. So what we tried to do was download 3.7 onto the Pis, but we couldn't figure out how to do that. We kept struggling, so eventually we just decided, okay, what we'll do is take what the problems were and convert that to 3.5, so then to get it up and running. Also, we had trouble getting the tests up and running because, as we said before, you can't start them on the same computer. You have to have different clients and services tested, and also if you want to test it, you have to run Redis. And that was something that we really wanted to get rid of. So in the end, what we decided to do was that we needed to increase test coverage to figure out what was happening to the Pis, why we couldn't get it up and running, and see what's going on. So the one thing that was really preached to us from Dr. Coleman and through the Clean Code series you watched by Robert Martin is that you have to rely on your tests. Really have good tests, that way you can make changes and be confident about the changes you make. And one of the reasons we failed in this section is because the system was kind of based on the fact that we had this code coverage, but actually we didn't have what we thought we had. So we wanted to make sure that when we made a change, it was a good change and nothing broke. And we ran the tests and they passed, so we thought, okay, everything's looking good, we can continue. But in the end, when we actually ran the system, something wasn't passing. So because of this lack of test coverage, there were many changes we had to make when trying to set up the system that probably could have been avoided if we had created better tests than we did.
One of the mistakes that we made this semester was, as a team, was chasing a moving target. We frustrated ourselves trying to make improvements to code that was not in a runnable state. Every time we tried to get the server up and running, we thought we were one step away from fixing whatever issue we were working on. But instead we were met with another bug or another broken piece of code. Every time we solved one issue, another one popped up in its place. As the code was evolving, those changes that we had to make affected how we started up the server and started up the clients. And as a result, while we were changing what we did to get the system up and running, we were still fixing old issues that we were working on. And in hindsight, it's very easy to see that that's what we were doing, but you can see everything in hindsight. It's not very difficult. In the moment, we were just falling over ourselves trying to get the system up. So the moving target was our mistake, and it was a very frustrating thing to have dealt with for so long. We've been frustrated all semester, and we've spent a lot of time wrestling with what went wrong. And it has taken us a while to pull out what we want to present on from what we've worked on. We've spent the majority of the second half of the semester restructuring and refactoring, and that has been getting harder and harder to do because of how tightly coupled our system has been. We spent a significant amount of time lately on the project, wrestling and battling with the tight coupling of our system. And having done all this, the project still isn't in a great place. There's still a lot of work to do, and it's not exactly where we want it to be. So we've been thinking a lot about what direction we think we should proceed in, because we realized that not every knot can be untangled. So we've come to the conclusion that the best thing for us to do moving forward is what we're calling a soft reboot. And we believe that this soft reboot is better for the health of Mirrulations than continuing to push through the issues with restructuring and refactoring. What I mean by this is that we would essentially be starting over, but not completely. We wouldn't take all of the stuff we've worked on and just throw it away. In fact, there are many elements of the project that we have built that we can utilize moving forward into the summer and beyond. And there are a lot of positive elements to the project that have been vastly improved by the team and are worth keeping. And so what we want to do now is tell you a little bit about some of those pieces.
One of the first things that we can salvage is our overall architecture of Mirrulations. The idea of having the server first generate work, have our multiple clients call our server, and then having our server then save those results is still a very valid way of looking at this problem, and it should be considered for the future. Another thing that we could salvage is our endpoints in our structure. But during the summer, we had downloaded over 250 gigabytes worth of comments from regulations.gov. So we know at a high level, our interaction between client and server is working. We also know this because we have, during this semester, we have created acceptance tests that show that the end-to-end communication between client and server is working, but there are just some tightly coupled bugs that are preventing us from fully running. Another thing that we can salvage is our file structure system. At a top level, we have the various organizations from regulations.gov. And if you look at the top, you see it, FCIC, it has child directories. These child directories represent the various rules and regulations that the FCIC has proposed over the years. And we call these dockets. Inside the first docket, you'll see that there are another set of child directories. These represent comments that have been made for that particular regulation. The code we have to read and write to this type of directory structure it still works, and by having it set up like this, we do not have a need to save to some kind of database. And along with this data structure and our overall architecture, we can also save our acceptance testing.
So one of the really great things that is still useful to use in the future of Mirrulations is the acceptance test that we wrote. They're really a good way for anyone who's completely new to the system to just read and just kind of understand how to set up just a server and client instance. Here's just a pseudocode example of one of our tests. Just going through it, you set up like a mocked out server job, then you have the client do a post job to the return docs endpoint, and then whatever it gets back, we try to check see if we're getting back what we're supposed to be getting. Addition to that, we also have database job management using Redis. We made two basically job queues. One's called waiting and one's called in progress. This kind of allows us to check what the server is working on at all times, and especially when the server is going to be running for months on end, since it's going to take so long to download. It's nice to see what's going on all the time. And like kind of previously mentioned, our website is completely disconnected from the rest of Mirrulations. It's loosely coupled, and with our soft reboot, it really doesn't need to be touched that much in any way. It can just kind of be added in later. And in addition to that, there is also our documentation, which we're going to be able to salvage.
So one of the good things about us going through the project and doing some refactoring to the code is that we were able to make it a lot easier to use from a development side, consumer side, or from a website. We've been able to streamline the process of running everything, and we have that documented. All of those processes can still be saved. And on top of that, since we have been trying to separate the client, server, and web from each other, we've been able to make sure that the configuration files are separate for each package of the code. This can also be saved, and our process of using the configuration files doesn't need to be touched at all when we do the soft reboot. And lastly, our updated file system for the project itself, it works, and it's very close to what you would see in many different Python packages. We can keep this file system going, and this will help us create cleaner code by getting rid of any coupling that may be existing.
So moving forward, we have a few recommendations for the summer team. One of the largest recommendations that we have is that we make sure that the team who takes this on takes enough time to really understand the Mirrulations code, as well as the system and the acceptance tests that are in it. Due to the fact that we had people who hadn't seen this code base before, since we were given this code base, we had a mix of people who had seen this code base and a mix of people who hadn't. And the people who hadn't seen this code base before led to sometimes we didn't always understand every little thing that was going on in it. So for the summer team to take that time, make sure that everyone is on the same page, would be extremely beneficial to their progress. And we also say another thing is to make sure that the summer team uses test-driven development to make sure that they catch any issues that as they're going through and recreating this code, and it's caught early on so we don't have some of the issues that we are battling with currently. And we also think it's extremely important to work in small steps throughout the process. So again, as we mentioned, we had the whole issue with the moving target. We were working, trying to accomplish very large goals when we should be working in very small steps so that we don't get caught in the same pattern that we were caught in before. So along with the recommendations, it's also very important to be aware of the places that we did fail, so the summer team does not fall into the same traps.
So throughout this whole semester, we've had our successes, we've had our failures, but we've learned many lessons, and I feel that they're really valuable to us as students towards going towards the future. So one of the lessons we've learned was building a system towards a new system that is not optimized for the code and transferring it and having it run properly. We have the value of mocking things out, so having a test like database or a system, a dummy system that can check to see if dummy system that we can run against, so we don't have to make changes to the real in-process system and break that. CI, continuous integration, so that we can make the code base much easier to change, and it changes as we go on with continuous integration and continuous development, and making small goals instead of big steps so that we can have rollbacks if anything does break, And with these small goals, we don't push ourselves into a situation where we have to make a big fix.
Left the word out there. Learn.
Yeah.
One final lesson that we found to be invaluable in this experience has been communication with your team members. Staying aware of what other groups are doing in your project allows us as individuals to make conscious decisions and be more mindful of what we are trying to do. We saw this good communication happening when we were using either our Jira board or our GitHub repo, and we would highly recommend that the summer team continue to use those processes, along with the Scrum meeting process, to at least gain a general idea of what your other teammates are doing. So the main point we want to make is that with good communication, you reduce the chance of doing duplicate tasks or doing work that you will need to eventually change because of work that was previously done by teammates. And with that, thank you for your time and attention, and the floor is now open for questions.